All right, today we're looking at lesson 9.1 and identify number patterns on an addition table. Now here in the classroom, we did the Spark Your Learning with our groups, but we're going to go over it. First, we went over the identity property. It says, I can identify number patterns in an addition table. I can use the identitive and commutative properties of addition to complete the equation. Okay. So the identity property Brecken read to us states that anytime you add 0 to a number, your sum will be that number. And the commutative property says you can add 2 or more numbers in any order and get the same sum. So then they were supposed to go down and fill in the table. It says Jamie uses addition table to find sums. As he records the sums in the table, he sees a pattern. What pattern could he describe? Well, let's first go back and talk about, I know that some of you got patterns, so let's talk to this front group here. What pattern did you find? That you added 1, whether you went across or down. Hudson, how about your group? What pattern did they discover?
So we started counting by ones at the top, and then I figured out that every number is down, and it just keeps going until you get
By adding 1, right? Yeah. Okay, and Catherine, did you guys discover anything different? The diagonal numbers are the same, aren't they? Okay, let's talk about what this means. If I have 0 plus 0, what is that? 0. What if I have 0 plus 1? And 0 plus 2? And 0 plus 3? Okay, and here we're using our identity property anytime we add 0. What if I have 0 plus 5? And then so 0 plus 6 is? Now, what number am I going to add if I fill in this row across? 1 to each of those numbers. So 1 plus 0 is? And 1 plus 1 is? And 1 plus 2 is? Could I go this way? 3 plus 1 is? So I'm using my commutative property, right? I did 1 plus 0. I could also do 0 plus 1, right? So I can read this table anyway. And then so 4 plus 1 is 5, and then 5 plus 1 is 6, and 6 plus 1 is 7. And you're right, it increased across by 1 every time, didn't it? And I can see as I go down that it's going to increase up by 1. Now, the whole purpose of this table is to help you with your addition facts. Okay? So if you didn't know what 3 plus 6 was, you could go to the 3 and go across to the 6 column and find out that it was 9. Or you could go to the 6 column and go down to the 3. And wherever those two meet is your sum. So you were all right that you added 1, whichever way you went, either if you went down the columns or across the rows. But really the purpose of the table is to help you with your addition. So what would the addition problems be for this sum of 6? What 2 addition problems could we write for this sum of 6? Reckon what's 1? No, this 6 right here. What's at the top? Right. And that would equal 6. Okay. So, Aiden, can you tell me what the other addition fact would be for this? We're going to use our commutative property here. We could start here with plus, right. So there we use the commutative property. Okay. And you can do that with any of the numbers on the table. So you should have filled your table in, and this would be 2, 3. I'm going to have to move my table up. 4, 5, and 6. Then 1, 2, 3, 5. Then 2 plus 2 is 4. 2 plus 4 is 6. And 2 plus 5 is 10. 3 plus 3 is 6. 3 plus 6 is 10. 4 plus 3 is 7. Oh, I did. That should be over here. This would be 9. Sorry. Okay. Oh, I sure did. How did I do that? Okay, so let's continue. 5 plus 2 is 7. 5 plus 3 is 5 plus 4 is, and 5 plus 5 is. Then we have 6 plus 2 is, 6 plus 5 is. And then if you go to the turn and talk, it asks you to shade all the squares that have the sum of 6. So you all discovered what? That it is a slanted or diagonal line. What if I shaded all the 8s? It would be that same thing, right? As we go down our table. Okay, so this is the commutative property. If I used 0 plus, if I wanted to write 2 sentences for this sum, I knew the identity property would be 0 plus 3, right? And anytime I add 0 to a number, our sum is that number. Okay. Okay, now we've turned to the Build Your Understanding on page 242. And it says John uses patterns to find the sums in an addition table. So the first thing John found was finds 0 plus 3. So he's at 0 and he goes over to the 3. And what did he get for his answer? 3, because anytime we add 0, we get. Okay, and then if he did 5 plus 0, what would he get there? A 5. Then it says, write other sums with 0 as the add-in. So they want you to fill in this top row and the first column. So go ahead and do that. So there's some confusion in the room about what you need to fill out. You need to fill out this row and this column, because 1 plus 0 is 1, 2 plus 0 is 2. Okay, you need to finish clear down to the bottom. 10 plus 0 is 10, and then clear to the end. 10 plus 0 is 10. And you need to fill in everything in between. Okay, so when you get done with your table, it should look something like this. You should have filled in the top row here and the first column. So check your paper if you're watching this. What pattern do you see when you find the sum of any number and 0? What pattern do we see? We use our identity property. The sum is always what? That number. Let's go ahead and type that, or I'll type it in. You write it in. You should put the sum is the same as that number. Okay, so the sum is the same as that number. That is what property is that? The identity property. You need to keep that in your brain. Of addition, because the identity property of multiplication is different. The identity property of addition. Anytime we add 0 to a number, your sum will be that number. John finds 2 plus 4 and 4 plus 2. What property is that? The commutative property. Choose a column and a row with the same add-in. Write the sums. So you choose a column and a row. Whether you choose 2 like that you're going to add to the 5s. 5 to every number over here. Okay. And then choose one down here. Maybe you choose 8, and you're going to add each number from the top down into the 8. If you have a hole where the notebook punched out, you're just going to have to leave that number out or write it out to the side. So go ahead and choose a number at the top that you're going to add 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to, and a number from the side, the blue side, that you're going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to. Okay, we're going to start with Catherine. Catherine, what number from the yellow did you choose to add? 5. So can you tell me what's down your column? You have a 5 and then what?
6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Okay, because 10 plus 5 is 15, right? Okay, Vivian, what row did you do?
I did 4.
So 4 plus 0 was 4, right? 4 plus 1 was 4 plus 2 was, they already did that one for you. 4 plus 3 was, yes. 4 plus 4 is,
8.
and then 4 plus 5 is, and 4 plus 6 is, 4 plus 7 is, 4 plus 8 is, 4 plus 9 is, and 4 plus 10 is. Okay. Anthony, what column did you do down?
I did 2.
So you have this one. 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. Then 2 plus 3 is what? And 2 plus 4 is 6. 2 plus 5 is 7. 2 plus 6 is 2 plus 7 is 10. Then 2 plus 9 is 11. And then 12. Okay. Aiden, what one did you choose to do across? Hudson, what one did you choose to do across? 1. Okay, so 1 plus 0 is 1. 1 plus 1 is 1 plus 2 is 1 plus 3 is 4 plus 1 is 5 plus 1 is 6 plus 1 is 7 plus 1 is 8 plus 1 is 9 plus 1 is, and 10 plus 1 is. Caden, what did you choose to go up and down, or down the column? 10. Okay, so he has 10 plus 0 is 10. 10 plus 1 is 10 plus 2 is 10 plus 3. Then we already had done 10 plus 4 with Catherine's. 10 or okay, so 10 plus 5 is 15. 10 plus 6 is 16. 10 plus 7 is 10 plus 8 is 8. And 10 plus 9 is, and then 10 plus 10 is. Okay, Jason, what did you do across? Huh? Okay, he did the ones. What did you do down? 10s. You all did the same? Okay, Lexi. Lexi did 5 going down and 6 across. So we can fill in our 6 across. So 6 plus 1 is
7.
3 plus 6 is 6 plus 4 is 6 plus 6 is 7 plus 6 is 8 plus 6 is, and 9 plus 6 is. So if I was doing math and I didn't know my addition facts, I could say if they gave me 7 plus 4, I could go I could go